1.7 carboxylic acids and esters. So carboxylic acid, when you have a C carbon double bond with oxygen and single bond with OH, this will give you carboxylic acid. So here is the same thing. C double with oxygen, single bond with OH. So this is aromatic carboxylic. Let's see how we name that. Okay, if I want to name this, so we're looking at the main chain. So I know this end will give me carboxylic, right? We have a 3 carbon in the main chain, and it is double bond, is alkene. There's going to be pro and then oic acid. I don't have any branches because it's alkene. I put E, right? If it was alkane, no, everyone was single bond, was put propanoic. It would be A here. So here's another one. So the main chain is gonna be that. Is that C is double bond with oxygen and single bond with OH, which is 1, 2, 3, 4 is butanoic. And on second carbon 1, 2, there is the methyl attached, 2-methyl butanoic acid. So the student doing question number 1 and 2, properties of carboxylic acid. This is carboxyl group, double bond option, single bond OH. As you see, methane comparing to the methanoic acid, carboxylic acid, it's because of those OH is very polar, right? So of course the boiling point going to be much more bigger. As your oic acid getting bigger and bigger, your boiling point is increasing. Yeah. Preparing carboxylic acids. So if you have alcohol and you oxidize it, it gives you alcohol, aldehyde. So what happening? The reaction of the ethanol with O means you're making more bond with oxygen. Here is single bond with oxygen. Now you have double bond with oxygen. So this O, this H will get out. So H and some oxygen that is there make water, H2O. Again, you have the product of that. You're reacting that with oxygen. So here you need to make more bond with oxygen. That's why the oxygen comes and come here and become OH, right? There's OH here. And now this is oic acid. So it's ethanoic acid. Write an equation to show the control oxidation of the aldehyde to form butanoic acid. So butanoic acid is 4 carbon, 1, 2, 3, 4 carbon. Would it connect to double bond with oxygen and single bond with OH? Now, how do we form that? You'd have to think backward, right? There is oxidation of the alcohol. How this side will just be a single bond with hydrogen, and you oxidize that. So here we have C1, 2, 3, 4. And this is double bond with oxygen and just H here. This one has this is H2, this is H2, here is H2. I didn't write it down, but the same thing. Just knowing that oxidizing that all comes here and you will get this. So write a series according to show that the reaction needed produced a metanoic acid. This is metanoic acid. You have to think backward. You write that and you know the oxidation, kind of this was not there, right? So you just write it down there, so it's metallaldehyde. And then you take that one, you know, this side going to be a water will be produced. Now you have to guess what is going to be there. So you don't have this double bond. It was just OH here. So, you know, just write down that. You have to work backward to do these questions. So for this one, you can do question number 5 and 6. So from carboxylic acid to organic salt. So this is an acid, and here is alcohol, is oic acid. From the acid, OH will get out, and from the alcohol, H will get out from water, and the R prime O will attach itself here. See, this is the O attached here. So this will give you ester. This is esterification. So an oic acid, carboxylic acid, alcohol will give you ester. So this is esters, as you see, the esters getting bigger. Yeah, it's just the naming of that. So methyl butanoate. So the longest chain going to be main chain. O8 means because of the ester, you have to add O8. 1, 2, 3, 4, and at the other hand we have 1. So this is going to be like a branch. It's going to be methyl butanoate. Here, the main chain is the longest one, the one that has 1, 2, 3, 4, 5. This one, that's why this is going to be what? Okay, let me just correct myself. If you want to name that, the one that is attached to the double bond. So this carbon attached to what? Double bond with oxygen. And this is the oxygen that attached itself to this C. So the one that is attached to a double bond with oxygen is going to be your main chain. Here is your main chain, going to be 4. Same thing happening. This carbon attached to, so here, this carbon has double bond with oxygen. How do you know? Because there is no hydrogen here. But this carbon is just singly attached to oxygen. Therefore, this will be your main chain, butanoate, and 1, 2, 3, 4, 5 is going to be pentyl. The same things, this carbon attached double bond with oxygen. So this is going to be your main chain. That's why it's going to be ethanoate. And here we have 1, 2, 3, 4. Here is 3-methyl butyl. Yeah, 3-methyl and butyl. 2, 3, 4. Butyl, and here is methyl, and so on. So here is, again, this is the naming and the preparing ester. Again, the one that is that one with carbon and OH, this is your butanoic acid. OH from the acid and H from the alcohol will get out, and this will give you the ester. How do we name it? Again, the one that is double bond with oxygen going to be your main chain. So it's going to be 1, 2, 3, 4, going to be butanoate. And here it's going to be like a branch, ethyl. Here is another one, that your main chain gonna be the one that is the carbon attached to the having the double bond oxygen here. The 1, 2, 3, 4 is gonna be butanoate, and here like a branch. This is methyl. So now draw a structure diagram and write the IUPAC name for the ester formed in a reaction between propanol and benzoic acid. So here is my benzoic acid, oic acid. So you have benzene ring here, and carboxylic acid is double bond oxygen, OH is attached to that. So it's benzoic acid. And propanol. Propanol is have 3 carbon, and you have OH attached to that. So you know OH from carboxylic acid and H from alcohol will get out, and this oxygen attaches itself here, and this is what we have. So since the C double bond oxygen is attached to the benzene here, so you have to say benzoate, and this is like a branch propyl. You know, the water will be produced because OH and H is getting together. So write a condensed structural diagram for the esterification reaction to produce the ester. Write IUPAC name for each reactant. So here is the ester that we have. This is double bond with oxygen, right? Therefore, this is the one that is oic acid, means you have to attach the OH here. And this is your alcohol, the one that it has a single bond with oxygen, C. So here is going to be OH. And of course, this is your main chain, 1, 2, 3, 4 is butanoate. And here is ethyl attached to that. So you can do question 11 and 12. Properties of ester. Okay, the functional group of an ester is similar to carboxylic group, as you see. Of an acid, when it's a lack of comparison to an acid OH group, the hydroxyl group is replaced by an OR group. See, OH is now OR in ester. With a loss of polar OH group. So of course, the OH is very polar. Now you have that is less polar. And therefore are less soluble in water and have lower melting point and boiling point than their parent acid. So of course, the oic acid, the similar ester, compared to that, the oic acid is much more polar because of the OH. Reaction of ester hydrolysis. So if you have ester and you have a base like Na or H will be in form of an ion, Na and OH ion. This R prime group will get out and attach itself to OH, forming alcohol. And you have this become like an ion negative, see? Become ion negative, and here is Na positive. So as we will share in more detail in the next chapter, okay, that's okay. So just talking about this, the saponification, that's fine. Yeah, you can do these questions on page 68. Can do question number 2. Yeah.